morning. It is Thursday, June 4th. Today we're going to go back to Algebra 1, our favorite, and we are going to solve word problems by calling something x and expressing everything else in terms of x. Here are our notes right here for what I like to call in terms of x. When given something is less than, more than, twice, blah, 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 something, call something x and express everything else in terms of x. If you see a problem talking about consecutive integers are always one apart. So the first one we call x, and since they're one apart, we add 1 to each continuous one. And if we have even or odd integers, if we're looking at a number line here, if I'm talking about consecutive even integers, for example, 2 and 4, 4 and 6 are consecutive even integers. They're 2 apart. And similarly, consecutive odd integers, 1 to 3, 3 to 5, are also 2 apart. So whether it's consecutive even or consecutive odd, the first one is x, then it's x plus 2, x plus 4. Again, even odd are 2 apart. So you might be saying, well, 2 and 4 are even. Yes, but if I add an even number to an odd number, it's still odd. If x is 1, 1 plus 2 is 3, odd. So let's jump right into the examples. The Tigers played 78 games. If they won 8 more games than they lost, how many games did they win? So whenever you see more than, less than, double, I need to call something x, express everything else in terms of x. So the very first thing I'm going to do is I'm going to write the two things I'm comparing. We're talking about wins and we're talking about losses. So I'm going to write W and I'm going to write L. We need to call one of them x. Whichever one comes last, we're going to call x. So losses, I'm going to call x. Now they won 8 more than they lost. So what's 8 more than x? X plus 8. So again, whichever one comes last, call x. Express the other one in terms of x. They're both going to have an x in them. How many games did they win? Well, now that I have my expressions, I need to create an equation. They played a total of 78 games. So that means that their wins plus their losses must be 78. I'll just write that. I'm not going to write that for every problem, but I'm just going to write it here so you can see what's going on. Their wins plus their losses must equal their games played. So their wins plus their losses must equal the games played. You're not going to always be adding them. You have to look at the situation. Whatever the situation is, that's what you're going to do with your expressions. But to come up with your expressions, call the last one x, express everything else in terms of x. From there, I combine like terms. I do the algebra. I get 35. It's asking for how many games did they win. Well, wins is x plus 8. So it's 35 plus 8, which is 43. Again, call the last thing x, express everything else in terms of x, create an equation with those expressions, and then once you solve for x, make sure you answer the question and substitute into the appropriate expression. Find 2 consecutive even integers such that their sum is 22. So I'm going to write even integer 1, even integer 2. Consecutive integers should be easy once you know. The first one's going to be x, the next one's going to be x plus 2. Always, because they're always 2 apart and you're always calling the first one x. If there was a third, it would be x plus 4. Now that I have them, it says their sum is 22. So if I add the first one plus the second one, it's going to equal 22. From here, I do the algebra. I combine like terms. I get 10. It's asking for the 2 consecutive even integers. So the first one is x, which is 10. The second one is 10 plus 2, which is 12. So 10 and 12 are my two consecutive even integers. Again, for consecutive integers, x plus 1, x plus 2. For consecutive even or odd, x plus 2, x plus 4. I guess we can take a look at this one. Danielle's age is 2 years less than Jessica's age. Less than, more than. I'm going to list the things I'm comparing. I got Danielle and Jessica. Whichever one comes last, I'm going to call x. Danielle's age is 2 years less than that. So there's something special about the phrase less than. First of all, you need to know that less than is subtraction. The other thing that's special about less than is you have to switch the order. So if it's 2 less than x, it's x minus 2. Again, with the phrase less than, you're always switching the order in which you write them. So now from here it says the sum of their ages is 56. I'm going to give you a minute or so and try and finish the question on your own. Again, I'm going to give you a minute or so and try and finish the question. Danielle's age plus Jessica's age must equal 56. I do the algebra, I combine like terms, I isolate, oops, 58. X equals, a little messy, 29. The question is asking for how old is Jessica. Jessica is X. Jessica is 29. All right. I think we can skip number 4. I think we can skip number 5. I think we can move on to number 7. The population of town B is 10% higher than town A. So I've got town A, I've got town B. Whichever one comes last, I call X. And then the other one I express in terms of X. Now this one has to do with the lesson we did a few days ago. 10% higher. That means it's increasing by 10%. When you're increasing by a percent, you're adding it to 1, and I get 1.1. So if town B is 10% higher than town A, then you're multiplying it by 1.1. And again, that's something that we did a few days ago in the percents lesson. So if ever you're increasing or decreasing by a percent, you add or subtract that to 1, and you multiply. If there are a total of 105,000 people in both towns, so if I add town A to town B, I get 105,000. So it's the same thing when you're dealing with percents, but remember with percents, if you're increasing or decreasing by a percent, you have to add or subtract that to 1 and multiply whenever you're dealing with a percent. So to solve this, when I combine like terms, 1x plus 1.1x is 2.1x equals 105,000. Divide by 2.1, divide by 2.1, x equals, I'm going to use my calculator for that, because I don't know what that is off the top of my head. And I got 50,000. It's asking for the population of town B. Well, town B is 1.1x, so it's 1.1 times 50,000, and I got 55,000. So again, when you're increasing or decreasing by a percent, you're adding or subtracting that to 1 after you make it into a decimal, and when you're dealing with percents, you're multiplying. That's how I came up with 1.1x for B. The length of a rectangle is 3 inches more than its width. So I have length and I have width, length, width. Whichever one comes last, call x. The length is 3 more than that, so that's x plus 3. Now we're talking about area. This is another very common Algebra 1 question. Well, they're all common Algebra 1 questions. Area of a rectangle is length times width. So 40 equals length times width. I'm not adding them here because it doesn't say to add them. I'm not in this situation. Area is length times width. So now that I have my length and my width expressions here, I'm going to multiply them because that's what the situation calls for. Now to solve it, I'm going to distribute. And now we have Mr. X squared. We have a quadratic equation. So we've been dealing with linear equations. It can easily be a quadratic. He wants to party. Before he can party, everybody's got to come over. So 40's got to come over. Now that everybody's over, party time. Bubbles, factoring. First sign comes down. Positive and negative and negative. What multiplies to 40? And subtracts to 3. 5 and 8. Bigger number goes first. Set each factor equal to 0. Now we're talking about the width of a rectangle. You can't have a negative width, so x is 5. It's asking for the length. The length is x plus 3. 5 plus 3 is 8. So you can definitely end up with a quadratic equation when you're dealing with in terms of x problems. And if so, if you have that x squared, follow your Mr. X squared story. He wants to party. Before he can party, everybody's got to come over. That means everything needs to be on one side, which is what I did here. Once everybody comes over, they party with bubbles. That means you have to factor it. Don't forget to set each factor equal to 0. And in a word problem like this, because we're dealing with lengths, you would have to reject the negative. You're left with the positive. And then again at the end, answer the question. Since it's asking for the length, we're subbing into the length expression. That's pretty much the same thing. I'm just going to start this one for you just so we can see another percent one. And then after that, I'm going to let you guys practice. Jack is building a rectangular dog pen that he wishes to enclose. The width is 25% more than the length. So this is another area, length, and width one. Whichever one comes last, I call x. The width is 25% more than the length. So because it's 25% more, because we're increasing by 25%, I'm adding 1 plus 0.25 to get 1.25. So what's the expression for the width going to be? I'm giving you a few seconds to think about it on your own. (1.25x). The area is 45. I know that area of the rectangle is length times width. So 45 equals x times 1.25x. From here, I do the algebra. There's nothing to distribute here. X times 1.25x is 1.25x squared. Divide by 1.25. X squared equals 45 divided by 1.25 is 36. Square root. X is 6. It's asking for the width. Well, the width is 1.25 times x, which is 6. 1.25 times 6 is 7.5. So if you don't feel comfortable with this, go back to the percents lesson and then come back to this, because you definitely have to understand the percents lesson in order to do that step. Otherwise, when you're comparing things, whichever one comes last, we're going to call x, express the other one in terms of x, create an equation based on the situation and solve, and then make sure you answer the question at the end and you substitute into the appropriate expression. This is not the easiest, simplest lesson, so I'm going to give you an extra day to do it. This will be for June 4th and 5th. Your classwork / homework for Thursday and Friday is to finish the worksheet, and your quiz will be due Monday night. Any questions, reach out to me and remind. I know not the simplest lesson. You probably have memories of this from Algebra 1, but hopefully at this point in your education you feel more comfortable with it. And again, like I just said, if you have any issues, reach out to me and remind. And I hope everybody has a great day.